You guys get the idea. Any questions about that? Kurt, anything to add?
No, I just wanted to see an example of when we talk about monitoring resources, CloudWatch is the service, and that's just one way to monitor your system.
I got my email.
All right, so just a little bit more here and we'll change activities. The other thing we thought it was important to kind of emphasize again is this idea of a container. And to tell you the truth, before a couple years ago, I had never heard of a container, so it didn't really make a lot of intuitive sense to me. But what a container is it's a way to virtualize your operating system. So what does that mean? We've talked about the hypervisor is a way to virtualize your hardware, right? We have all these different EC2s existing on one physical server. So that's a hypervisor that virtualizes the hardware into multiple computers. Well, this is kind of another way to take one of those servers and then virtualize that into something they call a container. It's a way to run an application in a very small part of a computer. Let me just jump to this 59 here. No, sorry, it's this one right here, 59. So what this slide is comparing is it's comparing virtual machines, right? These are the EC2s that we've been talking about so far, and that's multiple instances or virtual machines on a server. So hopefully you've kind of got that idea. And today what I did is I started up an EC2 instance, and then I loaded the web server, and it started acting as a web server. So that's what I did on a virtual machine. A container, what it is on the EC2 instance is you load a program, and one of the programs that's a container is something called Docker. When you hear somebody talk about Docker, they're talking about containers. Once the engine is up and running, then you can actually deploy multiple applications that are called container instances that all run within this Docker engine that all run on a single EC2. So it's kind of like, I'm thinking about those Russian dolls where you keep putting little dolls inside of bigger dolls inside of bigger dolls, a babushka doll they call it. It's kind of like a babushka application is what it is. Okay, so let me just pause and see if Darren, you would add anything to that or anybody wants to ask a question, but we thought it was important for you to at least understand what a container is. Docker is an implementation of a container, and AWS has a whole subsystem of ways to manage Dockers.
And the only thing to add is this, and it's a little detailed, but this idea of a hypervisor, and that's the biggest difference, right? It's right there in your slides. The one significant difference is a virtual machine runs directly on the hypervisor, but containers run on the computer. That's the big difference to keep in your head. And remember, hypervisor is special software that runs on a big host of machines that are that basically coordinate all the different virtual machines that run on it, whereas you are all familiar with just a regular, operating system like Macintosh, Catalina, or Windows 10. Docker can run directly there.
Okay, and so just very quickly, so if you can kind of get your mind around what a container is and the idea that Docker is an implementation of a container, then I'll just mention very quickly that Amazon has something they call ECS, Elastic Container Service. It's a way to manage deploying all these Docker applications to EC2 instances. Okay, so ECS is the service that manages them. There's a second one that they've come up with called Kubernetes, which is an open source Docker implementation. So it's kind of like the equivalent of Docker, but it's just a different open source implementation of it. And they have something called EKS. So this is like ECS, except it's EKS for Kubernetes. So we've got ECS, EKS, and the last one is the way to keep track of all these. So they call that a container registry service, ECR. It's kind of like GitHub for containers, if you know what GitHub is. So for sure, our experience is you're going to see these on the exam. They're going to mention containers. They're going to mention these services. So just trying to get you to think about what the context of those container services are. Darren, would you be able to give us a little container demo?
Happy to. Okay, I've sent in the chat that same EC2 instance that I had CloudWatch running on. We saw that over here. I also installed Docker on top of that OS. So I grabbed that IP and then sent you guys that URL, and to no surprise, it's not working because I don't have it turned on. So when I reload the page, I have the same sort of fail to connect. I'm going to go to the console here, and you know, basically, Docker is so simple, and that's why it's become so popular, this idea of a container. I have one file, which is called the Docker file, which describes all of the software that I want on my container, right? So imagine this is, like Kurt said, a VM inside a VM, kind of. And so I chose a Docker container that would have a web server on it. It would install Apache. It would create a web page on it to greet you guys. And then I built that container, and all I have to do is say start. So now that Docker container is running. If I come back over to my browser, it says hello from GSB 570. So basically, I think at this point a diagram is helpful. Let's go from the Amazon world and then kind of talk about it a little more. So in Amazon, we talked about a VPC that should be familiar to you. Inside the VPC is a subnet. Inside that subnet, I have this yellow EC2 instance, and then I've installed a Docker server or Docker software on top of that EC2 instance. So let's kind of blow that up and look at what that looks like. And so, you know, in this case, it could be Windows, it could be Linux. I have an operating system running on an EC2 instance. I can install Word on Windows and start using Word. And just like I installed Word, I can install Docker. And then on top of Docker, I can run other programs like a web server. So basically, that's all we did here in this example, and that's the web server that you're seeing right now. And so some of you might be asking, well, why is this, this sounds like extra layers of complexity. I don't understand why I would do this. Part of the reason is the portability. I could take the same Docker file and then just move it over to my laptop, right? And I'm running a totally different operating system. I'm not in an Amazon, right? I'm not in a virtual machine. I have my actual laptop. And I can take that same web server and it'll run identically, right? Which is really important when software gets complicated. There's lots of little configuration and thing you need to get stuff running. It's very nice to have a very consistent environment where I can maybe even do some development, make some changes here, maybe write an application. And then I have very high confidence that when I go to deploy that in Amazon, it's going to run exactly the same because it's so portable. So any questions about Docker and how containers work on top of Amazon? There's a lot of new terms. I'm amazed that there are no questions. We must have done an amazing job, Kurt.
Crystal clear, I guess. All right, I guess we're going to keep moving. So let's change activities here for a minute. So I'm going to post the So Creative quiz link. So if you'll open up the quiz page, we're just going to do a quick 5-question quiz on some of the content we reviewed right here. Again, we're just trying to hit the things we think are important and that you'll see maybe on an exam.
Share your screen, Kurt.
I sure will. Thank you. All right, maybe about 10 more seconds. All right, so this is true. Remember, we went down when I changed my instance type in lab 2 there, I had to pick those from the list. And each one of those maps to a type. And if you go look up T2 extra large, you can see how many CPU cores and how much memory is tied to that. So we're not free to mix and match ourselves. We have to pick one of their configurations. Okay, any questions about that? Next one.
We did that one quick, Kurt.
Oh yeah, sorry, thank you. Okay, so this is a little different than we did. This is talking about an AMI, an Amazon machine image, and sure enough, you can set one up in a T3 small, you can save the AMI, and then you can launch a new instance from that AMI. So it looks like most of you got that. Looking good. Next question. Five more seconds. For sure, if your workload, the type of computing job you have, is possible to run on a spot, that is the cheapest. Not everything is able to run on a spot because, of course, AWS can take it away at any time because they need it for something else.
And others, I see some of those answers, maybe they're thinking holistically, like depending on your use case, if you only need a machine for an hour a week, on demand's cheaper, but you know, we were driving for like overall cost per hour is the cheapest to spot.
Next question. 5 seconds. Yep, most of you got it dedicated. It's kind of like chartering a jet, right? You're not sharing the jet with other paying customers, it's your own jet. So that's a dedicated, by far the most expensive per hour, you know, depending on the size and all that. Last one? Nope, looks like there's one more after this. Five seconds. So C has to do with elasticity. That's the Amazon word for responding to demand. Buying reserved instances has to do with once you understand your demand very clearly, then it's easy to dedicate or say, we're going to commit to this. But picking an instance type and monitoring it is what they mean when they talk about right sizing it. All right, there's the last one. Five seconds. Yep, it's the thing that lets you observe real-time performance of your compute resources. All right. So Darren, why don't we do this? Why don't we, let's cover the Lambda quickly, and then we'll take a little break. Sound all right?
Yeah. Do you want to go all the way through your demo?
It'll be quick. You just give a little intro, and I'll get it all queued up here.
Okay. Okay, so Lambda is this pretty cool service within Amazon that lets you take some code that you've written instead of provisioning an EC2 instance, installing a runtime environment to run that code. You literally take your code and you copy and paste it into the Lambda console, and you basically say, here's this function I want you to run. Please deal with all the details of running this, which means finding a server, installing the right runtime environments, and executing that function. So it's called serverless because from your perspective, you don't actually need a server. You just copy and paste your code, and you don't worry about the details. But obviously at the end of the day, there is a box that runs it, right? So this diagram shows you basically. You take your function, you upload it, that function can be accessed a variety of ways, and then you only get billed for when that function executes. Pretty cool way to save a lot of money building applications. I started building serverless applications once I discovered this, and it's surprising how inexpensive these applications can cost based on you're only paying when the function itself runs. So multiple programming languages. There's basically no administration from my end. Fault tolerance is handled, and they also handle some scale. I really don't even have to worry about how much the function gets called, which is pretty nice. There is a way to tie these things together, which is cool. There is a bit of a limitation in that if I want to write a huge program, if I want to replicate everything the portal does, I can't really do it in one Lambda function. They can only, let's see, it's probably in there somewhere. I'll just say it now in case it's not. It has a 15-minute maximum execution time, so I have to write a program that can finish in 15 minutes, and then it has limited memory profile, and it also has, it's basically stateless, and what that means is, you know, it's you can't very easily keep something in memory. If a particular user did something, I have to either store that in a database in between calls, or I have to just, you know, write the application in a way that doesn't need to know about the last call that was made. So the way Lambda works is it gets what's called triggered, right? You have to come up with an event source that basically will, you know, get the Lambda function to begin executing. And no surprise, Amazon has integrated Lambda with many of its services, right? So you can do things like when you upload an object to S3, you want to execute a Lambda function. When you create a record in a Dynamo table, it'll run a Lambda function. So all of these things act as triggers, which is you know, how you actually execute this function at the end of the day. The more popular one, which is used, is something called API Gateway, and that's a way to call it over the web. So that's now how I write most of my serverless web applications, is I use API Gateway to do something over the web, and then that will invoke a Lambda function to process some information about that call to the web. So the configuration is pretty easy. You basically bundle up all your dependencies and you give it a role. So we talked a lot about IAM roles. We did talk about roles, right, Kurt?
At some point, yep.
Yes, we did. Okay. So you basically, just like we talked about the use of a role, remember a role is a way to delegate permissions between services, right? So if my Lambda function wants to talk to an S3 bucket, I create an execution role that says this Lambda can talk to S3. And so basically these three components are all you need to get going here. And then it basically writes its output to CloudWatch. We talked about CloudWatch earlier today. That's essentially where the results of my Lambda function get stored, which is convenient. So is this, how far am I going? I'm going through slide 75. So here is an example of a use case. Are you going to talk about this one, Kurt? Is this
I'm gonna do that. Yep.
Okay, great. So Kurt's going to basically explain this in more detail, but he's going to show you a use case where you can use Lambda with a CloudWatch event to trigger this function that will actually shut down an instance. I don't know if the use case is discussed in your lab, but I know we have a use case for this. We have a lot of developers that use EC2 instances during the day, and so we use CloudWatch to trigger an event that can look for those servers that are tagged with a development tag, and then use that to shut those instances down so that we save money while the developers leave the office. Go to sleep. A couple more slides here. So this is that example in more detail. Something happens, a S3 event occurs, you can trigger Lambda to do something, and then you can maybe even write the output to another target bucket, because remember, once this function executes, it's going to do its thing, and then it's going to basically go to sleep, so you can put the results in a resulting bucket. Oh yeah, here are the limits. So I can run 1,000 functions at the same time, like all at once. I could launch my function 1,000 times, which is pretty good throughput. There's a maximum size of how much space my code can be. That's pretty huge. We talked about 15-minute execution time, and then there's the memory limitations. basically 3 gigs of memory. So the function I write has to fit inside of all of this, right? Oh, this is the size of the code. This is function and layered storage. I don't really know what that means. That's the soft limit. This is definitely the limit of the size of the code that I upload. So anyway, in conclusion, it's branded as serverless computing, which from your perspective it is. You just write your code and push it to the Lambda service. It scales for me. It's fault tolerant. I really don't have to worry about much, which is a nice way to deploy code. It uses something called an event source that it uses to kind of operate on runtime to figure what was triggered and what data got passed to it. Limited to 3 gigs and 15 minutes. That's all I got, Kurt.
All right, so very quickly, I just want to show you an example. This is the activity in your Varkarum lab. It's after the EC2 lab. So there's a chance some of you may have already done this. But basically what it is we have a compute task we need to take care of, but we don't want to set up an EC2 instance to do it. Lambda is the answer to that. It's serverless, so we don't have to set up any instances to do it. And then we're just going to add a little bit of code. And what we're going to do is we're going to set up some code that basically shuts down an instance. So I've started the activity here. When I started it, it launched an instance for me. So you can see it's running. Okay. I came down here and I got that, oops, sorry. I got the little bit of Python code and I just copied it. And then I went over and I started a new function and I called it my Stopinator. And when I got here to my code, I just pasted my code right in this window right here. And it's not so important that you understand the code, but this is a little bit of Python that uses the SDK from Amazon, which is called Boto 3. I say, I'm working in the US East 1 region, right? And I knew that because I just went up here and saw it's US East 1. So I had to change that little text string. I had to give it the instance ID, right? That comes from this instance right here. And then all the other code was just the same. So that's the only code I want to execute. Okay, so I've got my code loaded. And then I just have to figure out how to trigger the code. And so we do that by adding a trigger. And what we're going to do is we're going to go and get a CloudWatch event. And we're going to say, hey, every 6 hours, every night at midnight, go run this code for me. And so that's what this is equivalent to. I've already got it set up right here, and I'm actually going to execute it every minute. So I'm going to execute the code every minute, and there's that's the code I wrote. I said rate, parenthesis of 1 minute, parenthesis. And that's all I do. And I add that. And this is now an active function. It's running. And so we have to wait about a minute before that function triggers, and it'll go off and run that code. So we'll just sit here for a minute and we'll watch it. And if everything worked right, it's going to come back and it's going to shut down my instance. I just had a little job I wanted to do. Every midnight, I wanted to run this code, a few lines of code. It's a great situation where I can use Lambda instead of running a server all the time to operate that function. All right, so that's kind of the punchline right there. Is pretty soon, there it goes. It triggered after 1 minute and it's stopping my instance. If I go back here and look at Lambda, I can go down to monitoring and I can look in the logs and I can see that that event happened. So again, CloudWatch is there, it's watching, and it's making sure and it's keeping track of everything that's happening. So there it is, it stopped my instance. All right, so that's what Lambda is all about. Any questions for Lambda? All right, we're a little bit overdue for a break, so why don't we just take 5 minutes, get up and stretch a little bit, and then we'll come back and kind of finish our plan for the day.
I'll be right back. Okie dokie.
All right, Darren, maybe we'll get going again here. We're going to talk quickly about Elastic Beanstalk, and then we're going to do another little Socrative quiz.
Sounds good. Okay, so Elastic Beanstalk is another service that Amazon provides that is considered a managed service. So anytime you see managed, we know that's good. They take care of some of the details that we don't like. And this framework is intended for web applications. So if I have a web application, again, that has all those layers, application server, web server, EC2, all that stuff, I can use Elastic Beanstalk to automate those infrastructure layers, and then I can just deal with the application itself, right? So it handles all the infrastructure deployment. It even does load balancing, so it can create 2 or 3 instances behind a central load balancer, and it'll scale. So not only does it handle the details of deploying that, kind of like a Lambda, but it also does some scaling for me, which is really nice. Here's kind of the anatomy of Elastic Beanstalk, right? It figures out which host, it figures out what operating system, it installs the app server, the web server, any language, libraries. It supports, here's the languages, Java, .NET, PHP, Node, Python, Go, and even Docker instances. And then just like Lambda, I upload my code and deploy it, and it deploys all the rest, and off I go. So, you can imagine the benefits are pretty simple, super easy for developers. It makes them spend their time on things that matter. And because it scales, it's difficult to outgrow. And I still have control over the resources. When I use something like Beanstalk, Kurt's going to show you, you can still see an EC2 instance getting launched. And so it does give you at least some visibility onto the underlying infrastructure, unlike Lambda, where you kind of see nothing. So anything to add, Kurt, or are you going to do our demo?
I think I'm going to do a demo. So this is kind of the third category of compute we've talked about today. We've talked a lot about EC2s. We talked quickly about Lambda, and Elastic Beanstalk is another way to do computing. And it is such an amazing, it's got a very specific use case. What this is for deploying web applications, right? So applications that run on a web server somehow. So this is part of the activity from Vocarum Labs again. And once I started it up, it had already defined an environment for me. So just like the picture Darren just showed, it builds all this infrastructure for you. And if I'm a web application developer, then I'm concentrating on the code. I don't really want to know a whole lot about the infrastructure of where I'm going to run this code. And so I'll show you really quick. What I'm going to do is I'm going to open a web application. And this is the source code from a web application. This is written in Java. It's actually all zipped up in a zip file. And if you come in here, there's a few YAML and some JavaScript stuff. And here's a few Java code files. So a web developer would develop this little application. They would zip it up, and then they just need to deploy that somewhere. And where the somewhere is Elastic Beanstalk. And so I'm going to open up this environment here. And very quickly, I want to just show you that the application runs at this website right here. So I'm going to open it up and click on it. And what you'll notice is the application's not deployed yet. I'm going to paste this URL into the chat window, because in just a minute here, there's going to be a web application running there, and it's going to be running on Beanstalk. The few details I would show you, if we go to the configuration, we can actually see the EC2 instances that are running here. And in fact, it's running on 2 T2 micros. That is the infrastructure that's been deployed. There's a bunch of other stuff here like load balancers and auto scaling. It's taking care of all those details so that the web developer can only concentrate on the code. So it's not important that we get to these details at all, but it's kind of neat to see how that if I wanted to, I could deploy my code on this. So here I go, I'm going to upload and deploy my code, and I'm just going to go choose that zip file I showed you just a minute ago. It's the Java application all zipped up. I'm going to open and I'm going to deploy it. And it's going to take just a minute to upload and get all those services running, but basically it's going to be a Java web app that's going to be running here. Okay, so just give it a minute here while it boots up, and then you're going to be able to reload that web application, and you're going to see that Java code running. So, you know, the important part is not at all that you're going to be web app developers. The important part is to understand that sometimes you're able to utilize something that a cloud service provider like Amazon has built that your people, your applications developers can use very quickly to get their apps up and running and even run real production workloads. Okay, I don't know if it's worth waiting around for this to load. It takes 2 or 3 minutes, and then you'll be able to reload that page. I think that probably is enough, Darren. Are we ready to move on?
Yeah, I'm just curious. Can you see the EC2 if you go back over to the EC2 dashboard?
Yeah, I have to go to configuration here. I can see the AMI.
If you just go to like the EC2 dashboard though, do you see the deployed?
Ah, gotcha, yeah. I think the answer is yes, so I could go to EC2. Oh, there it is. Yeah, so there's my 2 instances that it's running on right there.
It's pretty cool. So you don't have to deploy anything. It just deploys the EC2s for you.
It takes care of all that for us, yep. Anything else you'd add there, Darren?
No, your app's up.
Is it up now?
Yep.
Okay, I did not program that myself. There it is, yep. All right, so that's just a quick example of Elastic Beanstalk and the workload that you would use for that. You know, different than a Lambda situation, it's you want to run an app, you want it to be stateful and persistent, you want it to stick around. That's the compute tool you would use. All right, so the next thing I have is just a quick little summary of what we've talked about today. So we're going to do another Socrative quiz. So that's up and running. If you go back and open up the Socrative room, you'll be able to see the quiz. Looks like a few of you are getting there. I'll send it out one more time. So if you need the link to open up the room, there it is on the chat window. About 5 more seconds. All right, looking good. Yep, that's where you store your customized containers. So that's where you basically hold them until you're ready to deploy them. Next question. 5 more seconds. Yep, we used a CloudWatch trigger. That's how we triggered it. Next question.
You know what's weird, Kurt? The students get to see how many questions remain, and you and I, as the teacher, do not. You should add that to the teacher view.
Yep, I noticed that too. All right, about 5 more seconds. Okay, so I just wanted to kind of re-emphasize what stateful means. It happens that it comes up a couple times in the certification exam. Stateful means that you're able to remember your state. So if you started to do your homework and you had to go eat dinner halfway through your homework, you would leave and come back and you would pick up where you were. So you remember what your state was when you left. Lambda functions are not that way. You execute it and then you go off and do something else. You come back and you have to start from scratch again. It does not remember where it was. Most applications like Amazon.com cart, the cart is stateful. It remembers that when you log off and come back, it remembers what was in your cart. So that's an example of a stateful application that remembers things over time if you're interrupted and go away. Lambda is not. So just be aware of the difference between being a stateful application and a stateless application. Lambda is stateless. Five more seconds. Yeah, I actually think that A is true also. It does make auto scaling very easy because it does, you don't have to do anything. You just pick it, do you want it to scale or not? But that's not actually the best answer for this question. Elastic Beanstalk is set up to deploy web applications. That's what it does. Last question. Five more seconds. Yep, does anybody remember what the Lambda execution time limitation is?
Correct.
That's it. Yep, so 15 minutes or less, your code has to execute, but then a web app running on Elastic Beanstalk, it can go on and on and on. It can be stateful and go on and on. All right, good job. All right, so good. I feel like we kind of have covered the bulk of what we wanted to get to today. We just have a couple of things left, but I'll just take a breath and see if there's any questions. We've kind of recovered everything we're going to do on compute, and just see if there's any questions at all before we just do our last couple things.
There's a couple of questions in the homework yesterday. It says Kubernetes was an open source of EKS. I guess, yeah, I have questions about that, because isn't EKS a service while Kubernetes was like an orchestration tool? A tool is not equal to a service.
What was the second part again? What was not a service?
It's the Kubernetes was an open source version of EKS, but I thought EKS was a like managed service of Kubernetes on AWS.
The last thing you said is true. So the only point we wanted to make in the quiz was that before there was EKS, you know, the evolution of the containered services that Amazon provides, there was ECS, Elastic Container Service. And that's a, you know, proprietary, you know, implementation of a container managed service that Amazon provides. The community of container users out there were pushing AWS to offer a Kubernetes compliant container managed service. And so that's why they came up with EKS. And so I just mentioned that in the sense that ECS is not necessarily open source, EKS was born in open source. The Kubernetes, you know, was born in open source. Is that clear?
Yeah, and the registry service, isn't that the same as like the registry for like Docker pull or Docker push?
Yes, so Docker has its own public registry, right? ECR is if you wanted to have a private, you know, you didn't want your containers to be publicly available.
Okay.
And like there's a lot of internal services that you might use a container for, and it's just a convenient way to store those containers locally within inside Amazon.
Okay, thank you.
All right, so the next little bit is, it's not really covered in your course content, but it's kind of spurred by Izzy's comment last week that, you know, we're spending a lot of time on the content of this course, which is an introduction to the fundamentals of cloud computing. And she had kind of anticipated that it might be more related to things that you all do as data analysts. And so I think what we're going to do each time in the next few weeks is we're just going to kind of touch on something that is, it has a data analytics bent to the type of services. So the first one I want to show you today is a service in Amazon. It's called Rekognition. And what it is, it's an image processing service. It's a data algorithm that does very specific things with images and videos. And I just wanted to show you, we can't cover all of it, but I wanted to show you a few things. So I'm logged into my account here. I'm at the dashboard for Rekognition. And you can just come here and kind of cursor down through the demos, which are kind of interesting. So I'll just open with one that is the celebrity recognition. So what they have is they have a huge database of celebrity photos, and somebody's gone through and identified who those people are. And so you can see there's Jeff Bezos right there. And when the algorithm runs, it says, I'm 100% confident that's Jeff Bezos. But I can upload my own code here, and I could put in somebody like Michael Jackson, and of course Michael Jackson is in the database, right? It's only a 99% hit, but it's comparing the image I upload to their trained model of images of Michael Jackson. So that kind of makes sense. So there's one part of the service is we can do celebrity recognition. Another one that we can do is object and scene detection. So there's an image right there, and you run the algorithm, and it's able to identify different objects in the scene. Like, for example, you can see the labels it puts on the objects anyway right there. And there's even more. It's limited to how many you want to return, but it goes all the way down: architecture, office building, sidewalk. So it's got this huge database of objects that somebody's gone through and identified, and then we send it the image of this back into the car, and it's able to say, you know what, that's a vehicle. So I hope that's kind of making sense. And of course, I can upload my own image here, and I could maybe send it something like an assembly line, and sure enough, it can pick out people and humans, an assembly line, and a bunch of other labels. So it's able to detect objects in images. So say, for example, you had a whole bunch of images of objects out on the ocean, and you wanted to decide, is that a boat, or is that a whale, or is that a dolphin, or is it just a wave, some spray off a wave? So this would be the algorithm that you could actually train, right? So you could give it a bunch of images yourself and give it the solutions to that, and you could train this algorithm in Amazon and make it custom for what you're trying to do. Is that all making sense so far? Any questions or comments? So I also wanted to show you, really, this is just a demo, right? Like, how would you actually use this if you were doing some kind of analysis? And of course, with Amazon's everything's an API approach, you would write a little bit of code, and you would use the SDK to call the API to do the analysis for you. So what I've got here is I've got Jupyter Notebook opened, and if you're not familiar with Jupyter Notebooks, it's just like they actually call it R Notebooks, I think. I can't actually remember the name in R, but it's very similar. So I just go cell by cell, and I just execute the code. So the first cell right here, I've got it blown up where I hope you can see a little bit. I'm not really focused on the code, but I just kind of wanted to show you the method you would go about it. Is the first thing I do is I load the SDK library. So Boto 3 is the Python SDK. The next window, the next cell, what I do is I just get my client and I get some authorization. So I've got my credentials set up here, and I have to have credentials in order to use the service, because in the end, somebody's got to pay for it, and it's on my account. And then the bulk of the code is right here. And so what I do is I just send it a JPEG file, and then I make a call to the recognize celebrity, and I send it that image file. So this is me sending an image to Amazon, and it does its analysis, and then it responds with what it finds in the analysis. So that's what the response variable is. And it's a JSON object, so then I just have to parse through it in order to pick out the details I want from the response. And so I pick out a few things. I say, well, give me the celebrity name and give me their ID in the Amazon database. Tell me the confidence that you make the match with, and then just print those things out to the screen. So if I just execute this code right here, what you'll see down here is you'll see the response. And so it identifies Michael Jackson with a 99% confidence interval. So that's me making an API call to the Amazon service and using it here. So you can imagine in an analysis you're doing, there's some service that Amazon provides, and you don't want to use the console to interact with it. You want to use your R code, your R analysis, right? And so this is a way you would do that. And just to kind of play around with it a little bit, I could send it some other images just to show. Let's see, which is the most, this one's kind of interesting. So I'm going to send it a few basketball players, and let's see how it does with that analysis. So I sent it an image with 3 individual players in it, and it's pretty interesting that for sure it picks out Magic Johnson and Larry Bird, but it has trouble. It does not identify Michael Jordan. So for sure it's not a perfect database, like it's not a perfect analysis. There's some things that it fails on, but there's a lot of things it's successful on. And then I just found one example where it actually misidentifies somebody here. So I'm going to send it 3 movie stars. And it's interesting what it picks out and what it misses. So it's 100% sure it's Harrison Ford. It's 100% sure it's Sandra Bullock. But Captain Jack Sparrow is misidentified as Gabriel Garco, right? That's, I'm not even sure who that is, but that's Johnny Depp right there. And maybe because of he's usually wearing less stylish clothes, or he's got dreadlocks or something, or sunglasses, it can't identify him. So that's how you would use a service. Any questions or comments? Yeah, that's right. Michael Jordan is the greatest, right? Well, what do you think, Darren? There's 6 minutes left. I have a couple more. I was playing with recognition in a couple more ways, but I could also stop if you wanted to just prime them for the storage that's coming up next week. What do you say?
I'd say keep going on recognition. Sounds more fun.
Yeah, it's more fun. Okay, so how about we do, we did the celebrity. We could detect labels. We kind of saw that already. Let's do compare faces. This is kind of an interesting implementation. So this is not something you can customize. You're just stuck with what Amazon can do, but you can send it any 2 images and it can say, are those the same people or not? So it's the same pattern. I load the SDK, I get my credentials, and then here I just defined I define a method, and then I'm just going to call the method or the function. I'm going to give it a source file and a target file. Okay, so the first one I'm going to send it is an image of current day me, and I'm going to send it an image of me a few years ago without the wrinkles and the gray hair. And we're going to see if it says those are the same people. So I'm going to execute that, and sure enough, with a 93% confidence, it's sure those are the same person. And of course, if it's not a straight-on headshot, if it's the full body, it is able to pick out the face. And if you're doing a profile, it has less chance of making the connection. But anyway, that's kind of how it works. Okay, and you can see right now I've got the threshold set at it only makes a match if it's 90% or better. And so there's this one celebrity that people often tell me I look a lot like, and I've got that under the other 2 here. And so let's just test the algorithm to see if it's really true that I look like that other celebrity. So I'll execute that right there. And unfortunately, it says I do not look like Brad Pitt, at least for a 90% confidence interval.
Oh, totally wrong, Kurt.
I know, that's what I was saying. So, okay, well, if it's not 90%, maybe it's like 80, 85%, right? How about we cut that down to like I'm 50% like Brad Pitt. So let me recompile that function, and then I'll call it again, and let's see if it makes a match with me and Brad Pitt now. Nope.
Hello.
Sorry, not 90. So what do you guys think? Like maybe 20%, right? So am I a 20% match for Brad Pitt? Nope, not even 20. Okay, well we are both white, right? So if we're both white, so if I go down to 10%, and let's see if it thinks I'm 10% like Brad Pitt. Oh, there it is. I am 18.7% a match for Brad Pitt. So actually, people do tell me I look like a celebrity, except the celebrity is, you guys may remember this celebrity. People often tell me I look like the former president of Apple. I never really thought so, but apparently, according to the algorithm, I'm 53% like, what's that guy's name, Darren? I always forget the Apple guy.
Steve Jobs.
Oh yeah, Steve Jobs, right. No, I knew that. So anyway, it's fun to play around with some of the services in AWS. What are some of the other ones that you find pretty interesting, Darren, from kind of the analytics perspective? There's one that does voice recognition, right? What's that one called?
Yeah, Transcribe. We've used that in the past recently. You can send it a video with audio included or just an audio file, and it will translate and basically transcribe all of the words that were spoken in that video to the best of its ability. It does a pretty good job too. Sends you back a pretty nice, clear, logically oriented file so that you could find words in a video transcription. Kurt and I used that because we taught a class and we wanted to I don't know, edit the video or something, and it was like a 2-hour class and neither one of us could find where in the video it was. And I said, let's send the video to transcribe. So we sent the whole video to transcribe and looked for the words that we were saying, and then we found it right away. It was pretty cool. I'm trying to think of other ones. I mean, there's a whole series of like machine learning ones that are bundled under SageMaker to sort of train your own model. So along that same line that, you had talked about, that the recognizing the ocean and the versus boats on the ocean. You could use something like SageMaker to train your own models and stuff.
Yeah, so I've shown you one that's pretty much canned, and you just have to use what the model is. There's a little bit of customization you can do with recognition, but then Amazon has this whole infrastructure of machine learning algorithms that are not pre-trained. You have to train them yourself. And so that's definitely a different part of Amazon than we're covering this quarter, but there are just amazing opportunities out there to utilize some of these services. And the idea is if once we kind of get you the basis of how to use the cloud, then you're able to take off and really run very quickly, come up to speed on how to use some of these other services. So that was kind of the point to show you recognition today. Well, that's kind of all I had. Darren and I will hang out for a few minutes and see if there's any questions or interaction or discussion. Don't hesitate to stay on and talk to us. Have a great week.
All right, Kurt, I got to jet to that other meeting. I sent you a text in the chat.
Okay, Darren, I'll see you.